All right, recording is rolling. It is Tuesday, September 10th. It's going to be Projectile Lab Day. So, Projectile Lab, you guys have on your desk launcher. You guys got a ramrod. You guys got some bouncy balls. You guys see this? Now, here, let's talk about how to put this together. You guys remember if this is sitting on top of the balcony out there? We're about to go out on the balcony in a few minutes. Okay. What do you do first? Do you put the squishy ball in first and then ramrod it, or do you ramrod it first and then put the squishy ball in? Yeah, ramrod it first. Otherwise, the squishy ball gets stuck in there. And if you notice real close, here, listen for a click. If here, click. Okay. You actually go 1, 2, 3 clicks. Okay. So the more you press it in, the more it's pressing the spring, and then the more spring force is going to be, the faster it'll fire. Just make sure that you're using the same setting over and over. So that could be sort of like a control variable. Think of it that way. Okay, like control. All right. So let's set up here. Yeah, I see a bunch of you guys already making this table. That's good. You guys can get a head start on this table. Okay, so like a bunch of these lab tables, there's a certain number of variables that you're measuring and maybe some things that you're calculating too. And so what are you measuring? What are you calculating? Okay. All right, so trying to figure out what is the blast speed of that launcher. Gonna tell you there's only one measuring tool that you're using, and that's a meter stick. Yeah, okay, you guys have meter sticks on your desk? You guys have meter sticks? All right. Now, some of you guys actually also throw out some trundle wheels. You guys see those trundle wheels? You guys know how that works? Guess what is the, okay, use this one for demo, for the video here. Okay. Guess what is the circumference of this wheel? 1 meter, 1 meter. Right. And as you roll it around, every time it goes around, I think it'll either click or there's like an odometer on this or something. Yeah, here it is. Yeah, there it is. Got an odometer on the back here. So I'll tell you how many meters. So if you want to roll that, instead of using the meter stick, you do that too. Okay. Some values I'm going to give to you. You're allowed to know the gravity field of the Earth, so pick your favorite value, either that or that. Okay. And I'm also going to tell you the mass of the ball is 7 grams. I'll go ahead and give that to you. Now, if this was an AP question and they told you the mass of the ball, they said, oh, here, that's a given value. Okay. Then the implication is that you don't need a measuring tool to measure that variable because it's already a given value. Okay. In this case, the mass of the ball is 7 grams. I measured a bunch of balls yesterday and they were all 7 grams. Okay. All right, so here's your setup. There are different ways you can determine the blast speed. Maybe while you guys are copying this table, I'll talk about a few of these. Right? So the one I'm actually going to have you guys do is sit up on the ledge, aim it horizontally, right, and then fire it and see where the ball lands out here. Okay? Now, the purpose of aiming it horizontally goes like this. Okay? Because if you aim it horizontally, then right when the ball is leaving the launcher, how fast is it moving vertically? 0 meters per second. It doesn't matter how fast it's going to the side. If you throw it slow to the side or fast to the side, or even if you just drop the ball. Because if you drop a ball at the same time you launch one horizontally, which one hits the ground first? Yeah, same time, which means they have the same vertical motion, which means they have the same time of fall, right? Okay? And that's going to be part of your calculation is to determine what is the time of fall based on this drop height. Okay? So if you want an equation to back that up, yeah, I should really have you guys fully flesh this out, but you guys know it's going to come from a modified version of the first kinematic formula. It goes like this: x equals v naught t plus half a t squared. Right? Or maybe I'll ask you guys. I think that's a good way to do it. So here's like straight from the poster what it looks like. But suppose I want to solve for what is the time of fall based on this drop height. Right? How can I modify this? Like instead of x for a general displacement, what would I call that in this case? Yeah, this height drop. So this would represent the height drop. Right? What would, see if you guys are following. Okay. What would this initial velocity be equal to? It is 0. It is 0. All right, I wasn't sure if you guys were gonna get that. It was a little tricky because this is actually not the blast speed. This is v naught in the y direction. Which is 0 meters per second right there. Right? As long as you aim it horizontally, it has to be aimed exactly horizontal, or you could drop the ball either way. Okay? But you guys can aim it horizontal. You guys see why that would be? Okay, and then plus 1/2 Ooh, guys, what's going to go in for this A right here? Yeah, 10 meters per second squared. So Earth gravity, 10 meters per second squared. Okay. And then what does this T represent again? Yeah, the time to get from here to here, which since it's a vertical equation is the same as the fall time. Okay. Okay. So you could solve for T like that. You guys can do that. Okay. The so as long as you know the drop height, you can calculate the fall time. Hey guys, what do you think is more accurate to determine the fall time? To do that calculation that we just walked through, or to break out some stopwatches to do like from firing point to crash point? What do you guys think is more accurate? Definitely the calculation method. Okay. If I had like a bunch of students and a bunch of stopwatches, you get times all over the place, and maybe you can take an average, like, right? But yeah, if you do that calculation that we were just talking about, it's gonna be a lot more accurate that way. All right, then the other measurement you need is to spot where does the ball land and get that horizontal displacement. Okay? Ooh, guys, if you know how far across the ball goes, and you know the drop time, could you determine how fast it was going across the field? Right? Would that be a constant value all the way across? Yeah, it sure would be. In fact, if you aimed the launcher horizontally to start with, is that horizontal velocity also equal to the blast speed? It'd be the same thing, wouldn't it? Right? Is it? Right. Yeah, there's a poster I went over at the very end of class that pretty much has the solution on it. Right, but see if you guys can figure that out. Okay. So I would come up with a table that makes something like this. Looks something like this. Yeah, okay, different trials could be like 1, 2, 3, 4, A, B, C, D, whatever. Okay. What's the drop height? Which I guess actually this would be a fixed value, wouldn't it? Okay. This drop height. Ooh, what's this landing distance? It might be, plus or minus a little bit. Okay. Maybe you want to do a few trials, take an average kind of thing. Maybe I should make a column for an average. What's the fall time? That would be something you can calculate. Just talked about that a few minutes ago. What's the blast speed? That's the whole purpose of the lab. Like your conclusion should say, conclusion, blast velocity equals so many meters per second. I think you do that. Okay. Also, before we go out there, I'm going to have you guys do this AP style write-up. So throw this up here. This AP style write-up. I showed you guys this yesterday. Okay. And then when you guys come back in, we'll score this. I have a rubric ready to go. Okay. So everybody has the same question. What is the velocity of the launcher? Trying to figure out. Measuring tools, let's say only a meter stick. That's the only one you're allowed to use. Okay. So everything else is either known or given. You're allowed to know the gravity field. You're allowed to know the mass of the ball. That's just a control. All right, procedure. I'm just looking for something real short, just a few steps. Just very briefly, what was the setup? Yeah, it's so much like about a couple other steps you could possibly do. Okay. What variables were you measuring, controlling? In this case, you're not really changing anything. It's not really an independent variable. You just fire a few times, take an average kind of thing. Okay. Oh, you might want to mention that, guys. That's always the point in this AP style. Right? Mention multiple trials. That's always the point on your AP exam. Okay. Analysis. I'm just looking for equations today. So can you plug in some of these kinematic equations and ultimately solve for V blast equals so many meters per second, which would be your conclusion. Okay. Here's your AP style, right? Okay. While you guys are jotting some of that down, let's talk about different ways you could set up this lab. I'm directing everybody kind of towards one way of doing it. Okay. But can you guys think of a different setup that you like? What's another way you could also calculate the launch speed of this blaster, of this launcher? How could you do that? Other than this particular setup of okay, yeah, I guess you could do that. I wasn't really thinking of that. True. Yeah, you could put the speed gate right next to it. Go, fly straight through it. Yeah, like a direct measurement. Okay, true. You could do that. What's another way you could do it? Shoot straight up. Yeah, could you guys do that? The launcher like straight up in the air, goes to some maximum height, and based on that maximum height, H max, you could determine what was the blast speed. You could do it that way, right? How about this one? This one's a little trickier. What if you launched it at some angle and it lands some distance downfield, the horizontal displacement? If you know this angle theta and where it lands, do you think there's enough information there you could figure out how fast it was blasted? Yeah, you could do it that way too. That would be probably the trickiest way. Okay. All right. You guys about ready to go outside? All right, so we'll go outside, be out there a little bit, and we'll come back and we're gonna score your guys' AP write-ups by the time we're back in here.